Good evening, students. Today I am going to take linear differential equation with constant coefficients. A linear differential equation with constant coefficients is a differential equation of the form an nth derivative of y with respect to x, an minus 1, n minus 1th derivative plus so on a2 second derivative, a1 first derivative plus a0 y equal x. An equation of the form an nth derivative, an minus 1, n minus 1th derivative of y, so on a1 first derivative, a0 y equal x, where this an minus 1, a2, a1, a0 are constants, and this capital X is a function of x. It may be sine x, cos x, log x, e to the power ax, a polynomial in x, and it's a function of x. Okay. Or this can be written as an dny, an minus 1 dn minus 1 y, a2 d square y, a1 dy plus a0 y equal to x, where this dn is dn by dxn. That means d square is d2 dx2 and d is d by dx. So if I will replace nth derivative by d raised power n minus 1 derivative by d raised power n, I will get an equation of the form an d raised power n, an minus 1 d raised power n minus 1, a2 d square, a1d plus a0 operating on y equal x. This is a differential operator. This is a differential operator operating on y gives us x. This is symbolically written as fd operating on y equal x. So, a linear differential equation with constant coefficients can be written in the form fd operating on y equal x, where this fd is this thing an minus 1, a2, a0, a1, these are all constants. That is why it is known as a linear differential equation with constant coefficients, and x is a function of small x, right? If these ans a1, a2, a3, so on, an are variables, then this is a linear differential equation with variable coefficients. We can solve it and we will solve it later on. However, for the time being, we are going to take up only linear differential equation with constant coefficients. So, I have a linear differential equation with constant coefficient denoted by fd operating on y equal x. Now, how to solve such type of equations? First of all, I will take up fd operating on y equals 0. I will try to solve fd operating on y equals 0. Right hand side is 0, x is 0. This is a linear differential equation with constant coefficient. Right hand side is 0. This is known as a homogeneous linear differential equation with constant coefficient. If right hand side is 0, x is not there. Its solution is given by something. I will just let you know what it is. I will try to write the working rule for solving a linear differential equation with constant coefficient. What is the rule? Number 1, put fm equal to 0. Instead of fd, I am writing fm. I will just explain why I am writing fm. Don't worry. I have to put Fm equals 0. This is a differential equation. This will be an algebraic equation. This will be an equation known as the auxiliary equation. This is known as auxiliary equation. Obviously, this auxiliary equation will have roots. Now, case 1. If roots of auxiliary equation Fm equal to 0 are real and different, say m1, m2, so on, mn, then the solution of 1 is given by y equal c1 e raised power m1x, c2 e raised power m2x, plus so on cn e to the power mnx. If this equation has real and different roots m1, m2, mn, then the solution is given by c1 e to the power m1x, first root, c2 e raised power m2x, cn e raised power mnx. Okay, I will explain this also, why I am writing the solution in this form, why this is the solution. But this solution is known as, complementary function. Complementary function. This is case 1. When roots are different and differing roots are real and different, then the solution is given by this. Now, if roots are repeated, case 2. Case 2. If roots of Fm are repeated, what is Fm known as? It is known as the auxiliary equation. Say m1 equal m2 equal so on, mn equal m, all are equal, then complementary function, the solution, which is y, is c1 plus c2x, c3x square plus so on, cn x raised power n minus 1 e to the power mx. I will also explain this, why this is, the solution is like this. c1, c2x, c3x square, cn x raised power n minus 1. If you have two roots, m1 and m2, you will go up to 2. c1, c2x. X means n minus 1, 2 minus 1, right? If you have three roots, c1, c2x square, c3x, c2x, c3x square means 3 minus 1. So if you have n roots or m roots, then the solution is up to n minus 1 or m minus 1, whatever the case may be. If you have 5 repeated roots, the solution will be up to c4 x raised power, c5 x raised power 4 only. Okay, I will also explain this, why this is being written in this form. Now, case 3 is that if roots are imaginary, complex roots. Case 3, if roots of the auxiliary equation Fm are complex. And you know complex roots occur in conjugate pairs, say alpha 1 plus minus I beta 1, because they occur in conjugate pairs, alpha 2 plus minus I beta 2 plus so on, alpha n plus minus I beta n. Then the solution is given by Cf, which is y in this case, is C. First case, this is alpha 1, this is beta. E to the power alpha 1x, C1 cos beta 1x, C2 sin beta 2, beta 1x. This is the first factor. Second one is e to the power alpha 2x, c3 cos beta 2x, c4 sin beta 2x plus on e to the power alpha nx, cn cos beta nx, cn dash sin beta nx. This is it. I will be explaining this, why I am writing the solution in this form when roots are complex. Okay, you have to remember these three rules. You have to remember it once for all, because you will need it for every time in your first semester also and in your second semester also. Okay, now let me tell you why I have written the solution in this form. Okay, now there are prerequisites. See, what is the solution of dy by dx minus my equals 0? You know, this is nothing but dy by y equal m dx. You can separate the variables, dy by dx equal my or dy by y equal m dx, or you will integrate it log y equal mx plus some constant of integration, say log of c, or this is log e to the power mx plus log c. This is log m plus log n, so this is log mn, c e to the power mx, and this is log y. So what is y? It is c e to the power mx. So if you have a solution, differential equation of the form dy by dx minus my equals 0, its solution is always e to the power mx type. Y equal constant times e to the power mx. See, this can be symbolically written as d minus m operating on y equal, because you know d by dx is d. This is dy minus my equals 0, which is d minus m operating on y equals 0. This is an operator, differential operator operating on y equals 0. And this is a solution. If we find its solution is given by y equals c e to the power mx. This is the solution because, you see, if your y is equal to c e to the power mx, what is d of y? Means differentiation of y with respect to x. It is cm e to the power mx, right? Differentiation of this function with respect to x, it is c e to the power mx is m e to the power mx. Now if you have this question, dy by dx minus my, dy by dx, what is dy by dx? cm e to the power mx. M, what is y? Y is c e to the power mx. You see, I will get an identity, I will get a 0. So this is a solution. So if d minus m operating on y is equal to 0, its solution is given by c e to the power mx. Okay, remember it once for all. If you have a question, say d minus 2 operating on y equals 0, what is the solution? Y equal to constant times e raised power 2x. If you have d minus 3 operating on y equals 0, what is the solution? Y equal to constant times e raised power 3x, right? If you have d plus 2 operating on y, this is nothing but d minus of minus 2 operating on y. So solution will be y equal constant times e raised power minus 2x. Instead of plus 2, you have minus 2x. Clear? Okay. Now let me come to cases which I have defined just now. Okay. So I have seen that if I have d minus m operating on y equals 0, the solution is y equal constant times e to the power mx. This is clear. Now, if I have two repeated factors, d minus m operating on y equals 0. These are two repeated factors. This is d minus m, and let me suppose that d minus m operating on y is equal to u. Then, as per this is d minus m operating on y, I will get y. This is d minus m operating on u, I will get u. What is the solution? U equal constant times, let me write that constant c2. constant times e to the power mx. Fine. Compare these two. See, d minus m operating on y. Solution is y is constant e to the power mx. D minus m u. U is equal to constant e to the power mx. But what is u? This is u. This is d minus m operating on y equals c2 e to the power mx. What is d? It is d by dx. So dy by dx minus my equal constant times e to the power mx. What is this now? This is a linear differential equation. Dy by dx plus py equal q, or dy by dx minus py equal q. What is p? P is minus m. This is q. So what is the integrating factor? E to the power p dx. So its integrating factor is e to the power p. What is p? M minus m. So integrating factor is e to the power minus mx. Now what is the solution of this? Solution is y into integrating factor e raised power minus mx equal to right hand side integral c2 e raised power mx into integrating factor plus some constant of integration, say c1. dy by dx plus py equal q. This is the integrating factor. Solution is y into integrating factor equal right hand side integral of right hand side into integrating factor plus some constant of integration. This goes, this is c2x plus c1. So what is y? It is c1 plus c2x e to the power mx. E to the power minus mx. Here it will be e to the power mx. You can see if you have two repeated factors, you have to go up to 1. c1 plus c2x e to the power mx. If you have three repeated vectors, you can work it out. You will have c1 plus c2x, c3x square e to the power mx. Clear? So case 1 is okay, case 2 is okay. Now case 3. Case 3 is if you have complex roots, and you know complex roots occur in conjugate pairs. So you have one root is alpha plus I beta and another root is alpha minus I beta. Right? Case 3rd, I am discussing case 3rd, complex roots. Complex roots occur in conjugate pairs. One root is this one, another root is this one. Say this is m1 and this is m2. Now let us consider first case. If you have two different roots, these are two different roots. This is the complex root, no doubt about that, but this is different. This is different than this. If you have two different roots, what is the solution? Solution is c1 e to the power alpha or m1x, alpha plus I beta x plus c2 e raised power alpha minus I beta x. If you have two different roots, solution is c1 e raised power m1x plus c2 e raised power m2x. If you have three different roots, then c3 etc. and so on. This is okay. Now this can be written as e raised power alpha x. It is over here, it is over here. So it is c1 e to the power I beta x, c2 e raised power minus I beta x. I hope this is clear. E raised power alpha x, e raised power alpha x, this is out. What remains is this. Now you know, e raised power I theta, it is cos theta plus I sin theta. So let me write it here. E raised power alpha x, c1 cos beta x plus I sin beta x, c2 cos beta x minus I sin beta x. Fine? Or this is e raised power alpha x, c1 plus c2 cos beta x plus iota times c1 minus c2 sin beta x. I have taken cos separate and sin separate. So this is e to the power alpha x. A constant times cos, a constant times sin. Fine? This is what I had written in case 3rd. C1, C2, C3, C4, constants will be different. But solution will be if this is alpha plus I beta e to the power alpha x, constant cos beta x, constant sin beta x. Fine? This is all the three cases. Now, There's one more thing which I have used, which you don't know. I have used it. That is known as superposition principle. Superposition principle is that if y1 is a solution, y2 is a solution, yn are the solutions. If y1, y2, yn are the solution, then their linear combination c1, y1, c2, y2, plus so on, cn, yn is also a solution. This is also a solution. See why? If you have FD and operating on y equals 0, you know what is the solution. So y equal e raised power mxx, e raised power mx type. Now if y1 is a solution, then this will satisfy it. FD operating on y1 equals 0. If y2 is a solution, then f2 operating on y2 is equal FD operating on y2 equals 0. Let me take 2 only. Now if y1 is a solution, y2 is a solution, then c1 y1 plus c2 y2 is a solution. To see this, let me operate this FD on c1 y1 plus c2 y2. I can take up to yn also, doesn't matter. Now this is a differential operator. This is linear. This is c1 FD y1, c2 FD y2. Now FD y1 is 0, FD y2 is 0, so this is 0. So this is a solution. This is the general solution. That is why when I have said that if m1 is a solution, m2 is a solution, the solution is c1 e raised power m1x plus is because of this c2 e raised power m2x. If I have taken these repeated roots, then I have taken c1 plus c2x plus e raised power mx. This plus is because of this. If I have taken complex, I have c1 cos beta x plus c2 sin beta x. That is because of this. This is known as superposition principle. Now let me wind up. I have a linear differential equation with constant coefficients. It is solution. How to proceed the solution? I have to first find the auxiliary equation, which is fm equals 0. Now I have told you that I will tell you why I am writing fm equals 0. Okay, let me explain you that portion also. You see, you have d minus m operating on y equals 0. What is the solution? Solution is constant times e to the power mx. Let me not write constant. It will not matter. Or constant times, doesn't matter. This is the solution. Y equal e raised power mx. Now what is d of y? Differentiation of y is m e to the power mx. What is d square of y? It is m square e raised power mx. What is d cube of y? It is m cube of e raised power mx. Any derivative, dn is m raised power n. Let me add up these. D cube plus d square plus d operating on y. Right hand side will be m cube plus m square plus m operating on y. Means that if you have f of d operating on y, this will be f of m operating on y. But what is y? Y is e to the power mx. Let me write it. Fd e raised power mx will give me fm e raised power mx. This is clear. This is Fd, and if I will write y equal e to the power mx, this will be m cube plus m square plus m e to the power mx. Now, if our question is Fd operating on y equals 0, remember I am just discussing this case only. Fd operating on y equals 0, right hand side is 0. Now, Fd operating on y equals 0 means Fd operating on e raised power mx is 0 means fm e to the power mx is equal to 0. But e raised power mx is never 0, which gives us fm equal 0. And this is known as the auxiliary equation. That is why if I have Fd operating on y equals 0, I replace d by m and I write fm equals 0. No e raised power mx, because this is never 0. This is auxiliary equation, and the procedure is that if you get auxiliary equation which is obtained by replacing d by m, then you will get the roots. Case 1 is roots are different and real. Case 2 they are repeated, and case 3 they are complex. Let me take a few questions to understand all the funda what I have told you so far. Let me have this question. see d2y dx2 minus 3 dy by dx plus 2y equal to 0. This is a linear differential equation with constant coefficients. These are constant 1, 3, minus 3 and 2. These are constants. This is a linear differential equation with constant coefficients. In terms of operator, how will we write it? D square minus 3d plus 2 operating on y equals 0. Because you know d by dx is d, d2 dx2 is d square. Now auxiliary equation is m square minus 3m plus 2 equals 0. This is the method. You have to write first the auxiliary equation. You have written auxiliary equation. Now find the roots. Now your m is minus b plus minus under b square minus 4ac by 2a. So it is 3 plus minus 1 by 2. So your m is 1 and 2. 3 minus 1 is 2, 2 by 2 is 1, 3 plus 1 is 4, 4 by 2 is 2. Your m is 1 and 2. Roots are different and real. So what is complementary function? Y is equal to c1 e raised power 1x, c2 e raised power 2x. This is the solution. Very easy. Got it? Let me take up one more question. I don't think there is any problem in understanding this. D square minus 5d minus 6 operating on y equals 0. D square plus 5d plus 6 operating on y equal 0. Now, the auxiliary equation m square plus 5m plus 6 equals 0. Now what is m? Minus b plus minus under root of b square minus 4ac by 2a. So it is minus 5 plus minus 1 by 2. So what's m? Minus 5 and plus 1. It is minus 4 by 2. It is minus 2. Minus 5 and minus 1 is minus 6 by 2. It is minus 3. So complementary function. The solution is c1 e raised power minus 2x, c2 e raised power minus 3x. Got it? Fine? Okay. Let me have one more question. D square minus 1 operating on y equals 0. Simple question. Its auxiliary equation is m square minus 1 equals 0, which gives m equal plus minus 1. Because m square minus 1 equals 0 means m minus 1 into m plus 1 is equal to 0. So m is either 1 or plus 1 or minus 1. You have two different roots, 1 and minus 1. So what is the complementary function? c1 e raised power x, c2 e raised power minus x. Finish. Let us have one more question. Here you have d square d2y dx2 plus 4 dy by dx plus 4y equals 0. Okay. Now this is d square plus 4d plus 4 operating on y equals 0. What is the auxiliary equation? M square plus 4m plus 4 equals 0. What is that? M plus 2 whole square equals 0. Now see, this is the repetition. So m is equal to minus 2 and minus 2. What is the complementary function? It is c1 plus c2x e raised power minus 2x. c1 plus c2x e raised power mx. Your m is repeated, minus 2. So the solution is c1 plus c2x e raised power minus mx. Fine. Let me take up one more question. Let's have d square minus 2d plus 1 operating on y equals 0. So what is the auxiliary equation? M square minus 2m plus 1 equals 0, or m minus 1 whole square equal to 0. So m is 1 and 1. So what is the complementary function? It is c1 plus c2x e to the power 1x. c1 plus c2x e raised to the power mx, where m is 1. Fine? Okay. Now let me take one more question. Your question is d square plus 1 operating on y equals 0. d square plus 1. Now what is the auxiliary equation? M square plus 1 equals 0. What's m square? It is minus 1. This gives m is equal to plus minus iota. m equal plus minus alpha iota, means m is 0 plus minus iota, means 1 into iota. Okay, your alpha is 0 and beta is 1. So what is the complementary function? It is e raised to power alpha x, c1 cos beta x, c2 sin beta x. Fine? Beta is 1. c1 cos beta, c2 sin beta. Hope you understand this. Let me give you one more question. So you have d square plus d plus 1 operating on y equal to 0. Now what is the auxiliary equation? It is m square plus m plus 1 equals 0. What is m? Minus b plus minus under b square minus 4ac by 2a. So it is minus 1 plus minus under root of minus 3 by 2. So it is minus 1 plus minus iota root 3 by 2. So your m is minus half plus minus iota root 3 by 2. See, this is your alpha and this is your beta. So what is the complementary function? Y. It is e raised to power alpha x, e raised to power minus 1 by 2x. Constant c1 cos of beta, beta is root 3 by 2x. c2 sin root 3 by 2x. It's not necessary you write c1 and c2. You can write a and b, l and m, whatever you want to. One more question. I don't think there is any problem in understanding these questions, huh? See, what about d cube minus 6d square plus 11d minus 6 operating on y equals 0? This is a cubic. D square minus 6d square plus 11d minus 6. You can write the auxiliary equation as m cube minus 6m square plus 11m minus 6 equals 0. You can see m equal to 1 satisfies this equation. When m is 1, you have 1 minus 6 plus 11 minus 6. Minus 6 minus is minus 12 plus 12, it is 0. So you can use synthetic division. Coefficient of m cube is 1, then m square is minus 6, then 11 and minus 6. 1 into 1 is 1, minus 5. 1 into minus 5 is 5. 6, 1 into 6 is 6. This is always 0 because this is the root, remainder will be 0. So this is the differential equation. Differential equation is 1 into m square, 5 into 1, m, and 6 equals 0. Now this gives what is m? 5 plus minus 1 by 2. 5 minus 1 is 2, 5 plus 1, 3. So your m's are 1, 2 and 3. What is the complementary function? It is c1 e raised to power 1x, c2 e raised to power 2x, c3 e raised to power 3x. Got it? What about d4 minus 1? d4 minus 1. How will you write this equation, d4 minus 1? You see, its auxiliary equation is m4 minus 1 is equal to 0, which is m square whole square minus 1 square equal to 0. A square minus b square is a minus b, a plus b. For this, m is plus minus 1. For this, m is plus minus iota. So your m is 1 minus 1 iota and minus iota. So the complementary function is c1 e raised power x, c2 e raised power minus x, alpha is 0, e raised power 0 is 1. So c3 cos x, c4 sin x. c3 cos of iota है 1x, iota beta is 1. Whether it is plus 1 or minus 1, you know complex numbers occur in conjugate pairs, so we will get this thing only. This is the solution. You see, this was the 4th degree equation. I have got 4 constants. For second degree equation, second order differential equation, you will get 2 constants. For third order differential equation, you will get 3 constants. So another order differential, you have at least n constants. Okay. I hope you understand this. Now let me give you a question. It is 2d square plus 5d plus 2 operating on y is equal to 0. What is the auxiliary equation? 2m square plus 5m plus 2 equals 0. What is the m then? Minus b plus minus under root of b square minus 4ac, 4 to 8 to 16 by 2a, 2 into 2 is 4. So this is minus 5 plus minus under root of 9, which is 3 by 4. So your m's are minus 3 minus 5 and minus 3, it is minus 8. Minus 8 by 4 is minus 2. And then minus 5 and plus 3, it is minus 2. Minus 2 by 4 is minus half. So your roots are minus 2 and minus half. Roots are different and real. So what is the complementary function? Y c1 e raised power minus 2x, c2 e raised power minus half x. Okay, see it again, because I'm going to explain something out of this. 2d square plus 5d plus 2 operating on y equals 0. Auxiliary equation is 2m square plus 5m plus 2 equal 0. M is minus half and minus 2. Complementary function y will be this. This will be complete y. Okay. Now let me change this 0 by 2x plus 5. Now 2d square plus 5d plus 2 operating on y equal to x plus 5. Now is this a solution or this is an incomplete solution? What do you suggest? Obviously you will suggest that my right hand side was 0. This was the solution. Now you have right hand side is something. So you will have something more as a solution. Not just y. You will have some more function as a solution of this differential equation. You can see, so far as this is concerned, I have taken only 0 and my solution is this. But as and when I will take a function on the right hand side, solution will be different. It will be something. This is not the general solution. This general solution will comprise of 2 things. One thing is this is known as a complementary function. Another thing is a particular integral. Particular integral means a particular solution. Particular solution, and general solution is given by complementary function plus particular integral. Let me explain how and why. I am taking only this question and I am writing it as 2x plus 5. You have seen that the solution is given by c1 e raised power minus 2x, c2 e raised power minus half x. You already know this. Now I have a question. 2d square plus 5d plus 2 operating on y equal to x plus 5. You see, by trial method, if I will take y as x, if y is x, what is d of y? Yes, it is 1. What is d square of y? It is 0. It is first derivative is 1, second derivative is 0. Now let me substitute here. 2d square, it is 0. 5d, what is d? Y can be taken outside, d is 1. Then 2y, 2x is equal to x plus 5. You see, left hand side and right hand side is equal, means y equal to x is a solution of this differential equation. Now if y equal to x is a solution of differential equation, y equal to x is a solution of differential equation, then is it a complete solution? No, because you know its solution is given by this also. So the complete solution should be this one plus this one. Let me suppose that I know only this solution, I don't know about this solution. So how will you find? Because this solution is obtained only when right hand side is 0. Remember it. Keep it in your mind. Right hand side is not 0. So you cannot find the solution. I have found a solution y equal to x. But I know this is not the complete solution. Complete solution should be this plus this. But right hand side is not 0. So how I will take this equal to 0 and I will get this solution. Now let me explain you why should you take right hand side 0 even if this is a function of x. I have said that y equal to x is a solution. Fine. This you know, this I have shown. But you know also that this is not the complete solution. Complete solution is this plus this. So let us suppose that I don't know this is a solution. I suppose that there is something v which is a function of x. V is a function of x. Such that y equal to x plus v is the solution of this equation. Because I already know this is a solution. But here I don't know. So I have taken x plus v. Now what is dy by dx? Dy by dx. It is 1 plus dv by dx because v is a function of x. Now what is second derivative? Derivative of 1 is 0. It is d2v dx2. Now let me use in 1. Using these things in 1. This question is same as this question. This is 2d square y. This is d square y. So this is twice d square y. D square, what is d square y? 2d dx2. Fine. If you can write it as this function d2y dx2 5 dy by dx plus 2y. Okay. This question is same as this question. So 2d square, it is d2v dx2. Okay. Because of this. Then you have 5d. This is d. See, this is d square of y. This is d of y. And this is y. D of y, it is 1 plus dv by dx. Fine. Then you have 2y. Your y is x plus v. X plus v. And right hand side is what? 2x plus 5. So, this is 2 d2v dx2 5 dv by dx plus 5 into 1, it is 5. Then 2x plus 2v equal to x plus 5. Okay. You see, this is 2 d2v dx2 which is replaced by this one. 5 dy by dx. This is 1 plus dv by dx. 5 into this is this. Then 2y, it is x plus v. So this is it. 5 times this, 5 times this, 2 times x plus v, this is it. See, 2x cancels, 5 and 5 goes. What remains is 2d square, this is d square, this is d, plus 5d, plus 2, operating on v equal, this is the question. See, 2d square, 5d plus 2 operating on y equal to x plus y. But it is operating on v. And you know what is v. If you will find Instead of y you have v, right hand side is 0. Solution will be, this will have two roots, -2 and -12. Solution is this. So the solution is this plus this, because this is x plus v. Your v is, so whether right hand side is 0 or not, you have to take right hand side as 0 in order to get this. For this function, auxiliary equation is 2m square plus 5m plus 2 equal to 0 because of this. Okay, so I will be taking up in my next lecture, when your function f of d, your linear differential equation with constant coefficient, this is a function of x, and solution is given by not only complementary function plus some v, which is known as particular integral. Okay, so this is known as the particular integral. This is complementary function. Sorry, complementary function plus, but not this one is not particular integral. This is the particular integral. This is the complementary function, as I have said. This is the complementary function. This is the particular integral. This is the particular solution. X only. You cannot have 2x, 5x, 7x, or x plus 1, x plus 2. I will show this when I will take up ft operating on y equal x. I will take up this question and you will see exactly it is particular integral is given by x only, nothing else. Okay, so let me take your leave now. I will be taking next lecture tomorrow. Thank you very much.